All right, 8.5 is solving rational equations. Now, this is again comes back to this is the lesson that we've been working all towards getting us to solve equations. Now, when we're solving rational equations, let's take a quick review. Actually, we're going to go ahead and move on. Okay. When we're doing a quick, whenever we're solving these, the variable may end up in several different places, okay? Most of them are going to be fractions. The variable could end up in the top, variable could end up in the bottom. But regardless of all that we're going to do, everything that we have, okay, we have an x over 3, x over 10, and a 7. Well, first of all, we're going to want to turn them all to fractions. After we turn them all to fractions, we want to make sure that we have common denominators, okay? Just like when we added everything, okay? And if you look 3 and 10, 1 doesn't really matter because we can change 1 to anything we need it to. But 3 and 10, the numbers are 3, 6, 9, 12, 15, 18, 21, and we can add some more of those if we need. The factors of 10 are 10, 20, 30, 40, and so on. Well, we haven't got anything in common yet, so 21, 24, 27, there it is, 30. They both have 30 in common. So we're going to change these denominators to 30, okay? And when you're doing that, you're basically going to ask 3 times what will give us 30, okay? So we've got to multiply 3 times 10 to give us 30. So remember, whatever we do to the bottom, we have to do to the top. So the top gives me 10x. 10 times 3 will give me 30, so I've got to multiply the top, and I end up with 3x. And then 1 times 30 gives me 30, so I'm going to multiply the top times 30. So 7 times 30 gives me 210. So 10x minus 3x gives me 7x over 30 equals 210. Oops, this should have been over 30. Over 30. Okay. Now, once you get it to this phase, you can actually just cross off the bottoms, because if we multiply this side by 30, those cancel, and I multiply this side by 30. Remember, I do the same thing to both sides. And I'm actually left with just 7x equals 210. Divide by 7, and x equals 30. Okay. That doesn't always happen. That was just a luck of the draw. Okay. Example number 2 gives us 4 over x plus 5 over 2 equals 11 over x. Now, if you'll notice with this one, this example, our variable has ended up in the bottom of the fraction. So the very first thing we need to do is, I have an x in the bottom, so all the fractions are going to have an x. So let's go through and we're just going to add our x's. So that one already has an x. So when I add one, I have to add one to the bottom and I have to add one to the top. So when I add one to the bottom and I add one to the top, this is what I end up with. Then all you're looking at is coefficient of 1 and a coefficient of 1. So since they all have to have an x, now I'm just looking at what number does 1, 2, and 1 have in common. Well, the first number that 1, 2, and 1 have in common is 2. Okay? And now that I've taken care of the variables, the only thing I need to worry about now is 1 times what will give me 2. So 1 times 2, so I multiply the top times 2, and I get 8. 2 times what will give me 2x. Well, I don't have to multiply anything, so I can just multiply by 5x. Equals 1 times 2 will give me 2, so I multiply the top times 2, and end up with 22. Okay? And just like we did before, I can add 8x, so this turns to 8x plus 5 equals 22 over 2x. Okay? If I multiply this side by 2x, what happens is my 2x's cancel, but I have to do the exact same thing over here, so I can get rid of that stuff in the bottom. So then it turns into just a problem of 8x plus 5 equals 22. Minus 5 and 8x equals 17, and I divide by 8, so x is oh, wait a minute, let's back up a second. I apologize. I made a mistake right here. Scratch this. 8 plus 5x. So we get 8 plus 5x equals 22 minus the 8. So 5x equals 14, and I divide by 5. So x equals 14/5. Okay. All right, so let's go ahead and try example number 3 as a you try. So go ahead and pause the video and let's see if you can solve this one. Okay, so let's go ahead and first of all, we've got x's in the bottoms, so we're going to have to make sure and add our x. The other thing is I don't like minus problems, so let's go ahead and change this to a plus and change that 1 to a negative. Okay, just like the last one, our coefficients here are 1. So we find out that 1, 2, and 1, they both have a 2x in common. Okay, so then it turns into 1 times 2. So I multiply the top times 2, get 6. This one's already taken care of, so it's just a negative 1x. And this one I have to multiply times 2 to get 24. So 6 actually ends up still saying 6 minus x, or 6 plus a negative x, over 2x equals 24 over 2x. So again, remember I multiply this side by 2x to get those to cancel. Multiply this side by 2x to get the bottoms to cancel. So I end up with 6 minus x equals 24, or that could be a 1 there, minus your 6. So negative x equals 18, and divide by your negative 1. So x equals negative 18. Okay. All right, example number 4 is x squared over x plus 4 equals 16 over x plus 4. And if you look at, remember, if you look at your denominators, you find out that, hey, these are already the same. So we just need to get rid of them out of the bottom. So I got to multiply by x plus 4, and voila, those cancel. Multiply this one times x plus 4, and voila, those cancel. So I'm left with x squared equals 16. Take the square root, and x equals plus or minus 4. Okay. Remember, whenever you have an x squared, you're going to have 2 answers. Okay. All right, number 5. Now, right now, it does look here that this problem, we have our common denominators. The problem was with this 1. So remember, if I put a 1 underneath this thing, I find out that, oh, wait a minute, I don't have common denominators. So this one already has x plus 3. So all I need here is an x plus 3 on this one. So remember, I have to do the top and I have to do the bottom. So I get 2x over x plus 3 equals x plus 3 over x plus 3 minus 6 over x plus 3. Okay, so I can go ahead and combine 2x over x plus 3. Actually, now that, and actually a shortcut to this, let's do that. The shortcut to this, since all my denominators are the same, I can just simply mark them all off. We're done, okay? So I get 2x equals x plus 3 minus 6. Combine my like terms. So I get 2x equals x minus 3 minus x, and x equals negative 3 is my answer. Okay? All right, so the very last problem is 2x over x plus 3 equals 3x over x minus 3. Now, if we notice, we're like, oh, wait a minute. These do look like they have common denominators, but the problem is one has a plus sign, one has a minus sign. So they've got to be exactly the same. So if this one has an x plus 3, this one's going to have an x plus 3. Okay? Well, now this one has an x plus 3. This one has an x plus 3, so we're good. This one has an x minus 3, so I've got to add that x minus 3. So just like before, we're going to distribute. And now that my bottoms are the same, I'm just going to go ahead and mark them off because I'm actually done with them. So I get 2x squared minus 6x equals 3x squared plus 9x. Okay. So if I go ahead and minus 2x squared, I get negative 6x equals x squared plus 9x. And remember, whenever you have a squared variable and an x variable, it's got to equal 0 so we can factor it or use the quadratic formula. So let's go ahead and add 6x. So I get 0 equals x squared plus 15x. Since I have an x squared and an x, the option of this is going to be to factor it. And they both have an x in it. So x squared divided by x gives me x. 15 divided by x gives me 15. So remember, I set each of these now equal to 0. So x equals 0, and x plus 15 equals 0. So minus the 15. So I get x equals negative 15, and x equals 0. Okay. So make sure that you take a look at the practice problems. And if there's any further questions or anything we can help with, let us know.